In the next pair of examples, we want to find the x-intercept of a given log function, and then we want to look at the behavior of that function as x approaches infinity and as x approaches 0. To start off, to find our x-intercept, we need to find a point of the form x comma 0, meaning our y-coordinate has to be equal to 0. What we'll do then is set our equation equal to 0, giving us 0 is equal to log base 8 of 2/7 times x. In order to solve this, we'll convert this into an exponential equation again, which will give us 8 to the 0 power is equal to 2/7 x. Anything to the 0 power is just 1, so we get 1 to the 2/7 x. And then to solve, we'll multiply both sides by 7/2, which will give us 7/2 is equal to x. That means our x-intercept occurs at the point 7/2 comma 0. And then we can talk about the behavior of this function. First as x approaches infinity, and then as x approaches 0 from the right. We already looked at the general behavior for a log function. It looks roughly like this. So as x approaches infinity, our function value will also be approaching infinity. Even though that rate of growth is really slow, the function value is going to keep increasing. And as we approach 0 from the right, our function value is headed to negative infinity. Because again, log functions have that vertical asymptote at x equals 0. In example 11, we want to repeat this process, but notice what's different here is that now we have a negative out in front of that log. So we'll need to pay attention to that and see how that's going to play into this problem in a minute. Keep in mind that this is the same thing as the opposite of log base e of 7/4 x. Since we want to find an x-intercept, we'll set our y value equal to 0. And then the first thing we'll do is get rid of that negative sign that we have out front by multiplying both sides of this equation by -1. -1 times 0 is still just 0. And then we'll go ahead and convert this equation into an exponential equation by rewriting it as e to the 0 power is equal to 7/4 x. E to the 0 power is just 1. And then to get rid of that 7/4 times x, we'll multiply both sides by the reciprocal, which will give us 4/7 is equal to x. And our x-intercept occurs at 4/7 comma 0. Now we want to answer those same two questions about the behavior of our function, but keep in mind that we have that negative out in front of our log. What that does is flips this graph over the x-axis so that now instead of increasing as x gets larger, it's going to be decreasing. The rate of decrease will look kind of slow as x gets bigger and bigger, but it's still going to be headed to negative infinity as x grows larger. And as we approach 0 from the right, we still have that vertical asymptote at x equals 0, but now because the behavior has been flipped, our function is going to be headed to positive infinity.